Hello, welcome to our motor control POD at the SPS show 2013 at Texas Instruments. I have for you today 3 individual solutions to give an overview of what we're doing in motor control at Texas Instruments. The first one is being a DC motor control solution, a very simple one, but also highly integrated, very small. Next one is stepper motor control solution. And the third one is actually a full motion system that we have built up here for you. Let me show you the first one. Here we have our DC motor solution, a small H-pitch driver, and really we've put a magnifying glass on it so it's easier to watch and make sure when you look at it, it's the right chip on the right, the very small one. That's really the H-pitch drive here. Very simple. I can control the speed here, speed it up, or I can speed it down. Just a potty that's on here on this EVM. And I can also change the direction by simply putting this jumper here on it. Let me do this. That's kind of all to say about it. It is a very, very power-saving solution. So as you see, when you compare this with a competitor's device, in terms of motor control and battery consumption, we can show you that we can do a lot longer time we can stand here on this motor control. That's about this device. It also has a standby mode and of course a highly integrated solution. Next here is our stepper motor solution, the DRV8711. What we have done here is we built up here a stepper motor, and you see you have a motion control over this knob here. It converts this directly to the steps of the motor. It's fully integrated, that device, and it also supports micro steps. So I turn around, you see is now the movement is even smoother. Has all kind of protection modes in here, like a stall detect, has fully protection over overcurrent, and has an excellent thermal performance. If you want to look at it here, it's just like how it's over the maximum temperatures it reaches at the 3 amps or even at 9 amps. 24 volts, only reaching a max of 60 degrees Celsius. So that's so much about this solution here. And here's our 3-phase motor solution in suspend motion, where we make it the whole system on a 3-phase motor. Very simple, into your motion system. Everything in the software is already provided. It's based out of a Piccolo MCU plus a DRV8301. And on this Piccolo MCU, we have our software IP in suspend motion put into the secure ROM. That is powered by Spintax, Linestream Spintax speed controller. And let me show you a little bit what we're doing here. Is like the one thing is about bandwidth tuning. So this moves so small here, and I show you it's like at a medium bandwidth. How can I distort the system? So if I tease it a little bit, I've put the bandwidth very low, and you can see that I can waddle it around pretty easily. So it's really reacting to my movements here, but I can give it more bandwidth, and then it's getting stiffer and stiffer, the system. So really depending on how you want to remove stress from the mechanics or allow stress on the mechanics, you have here a certain stiffness in the system. The second thing that's fully controlled here is the jerk. So if I crank up the jerk a little bit, it each time calculates the trajectory. So this trajectory ends here at the bend. It's going to move now to the newer jerk, and I'm going to speed up the system, be a little bit more rocky to it. See how it's now playing with more jerk. I can crank up the jerk even more until I'm really getting concerned about my little water toy here on my conveyor belt. So here with maximum jerk, you see that it's really not taking any caution on my toy here. Or I slow it down again and say, please be nice to it. And then each time it tries to put the maximum speed on it, but it calculates the trajectory of the speed according to its movement in its movement plan. So there's really always the optimal performance of the system is guaranteed, and it's all done with the single bandwidth tuning factor on this one. Thanks for watching. A little bit of an insight into motor control at Texas Instruments. More information, of course, on the web.